Okay, this is a screencast taking you through Module 12, Lesson 1. And at the end, you should understand what a geometric sequence is and sort of how to write one. So the sequence 3, 6, 12, 24, 48 is a geometric sequence. In a geometric sequence, the ratio of successive terms is constant. The constant ratio is called the common ratio and is represented by R. All right, so for instance, to find the common ratio, you could take the second term and divide it by the first, 6 divided by 3. Or you could take the third term and divide it by the second, 12 divided by 6. Or the fourth term and divide it by the third, etc. Okay? But each time you do that, you get the same ratio. So the common ratio is R, and in this case, it's going to be 2 for this particular sequence. And then it says to use the common ratio you found to identify the next term in your geometric sequence. Well, if you have 48, in order to get the next number in the sequence, you would just say 42 times the common ratio 2, and you would get 96. All right. Suppose you know the 12th term in a geometric sequence. What would you need to know to find the 13th term? How would you use the information to find the 13th term? Okay, so for instance, if you knew the 12th term and you wanted the 13th, obviously you need the 12th term, and then you would need the common ratio because you would take the 12th term, whatever it is, kind of like up here, and you'd multiply by the common ratio to get the 13th term. Okay. This is an interesting question down here. It says, suppose you know only that 8 and 128 are terms of a geometric sequence. Can you find the terms that follow, or the term that follows 128? And if so, what is it? Well, you could, if you knew that 8 and 28 were successive numbers in the sequence, like that 8 was the first term and 128 was the second term. But if you don't know how many terms are between 8 and 28, then there's really no easy way for you to find out what the next term is. So the answer to number 2 is really it kind of depends. It kind of depends on whether you know whether those are successive terms or not. All right. Well, we've talked before about arithmetic sequences or arithmetic sequences. And when we did those, just recall that in an arithmetic sequence, successive or consecutive terms differ by the same non-zero number d, which is we called it the common difference. Here in geometric sequences, the common ratio of the successive terms is constant. Okay? So in arithmetic sequences, it was the common difference d. Geometric sequences, it's going to be a common ratio. Okay. All right. You're going to examine how the growth patterns in an arithmetic and geometric sequence compare. In particular, you're going to look at the arithmetic sequence 3, 5, 7, etc., and the geometric sequence 3, 6, 12, etc. Okay. So already I can look here, and I know that 3 plus 2 is 5, and 5 plus 2 is 7. So the common difference is 2. So I'm adding 2 each time. Here, from 3 to 6, I'm doubling it. Or in other words, 6 divided by 3 is 2. 12 divided by 6 is 2. The common ratio is 2. Okay? So let's go to the next page to continue this discussion. All right. So continuing on with the same set of numbers. This is an arithmetic sequence where you are creating a sequence by adding 2 each time. So this is a common difference of 2. Here it's a geometric sequence, and you are multiplying by 2 each time. Okay? So there's the big difference between an arithmetic sequence and a geometric sequence. Common difference, common ratio. Okay? Common difference D is 2. Common ratio, 6 over 3, is 2. You can do the second term over the first term, which is what I did here, or the third over the second, fourth over the third, what have you. Okay? All right. Let's look at how these sequences look when we start to graph them. An arithmetic sequence creates a linear equation The graph is a straight line. Geometric sequence creates a curve because it's doubling each time. Okay, so I will show you in just a second what that looks like. Okay, when we graph the two sequences from the previous page, the red is the arithmetic sequence, and if I connected those points, I would connect them in a straight line, okay, because I'm just adding 2 each time. But the purple, notice that it doubles each time, and so the line is a curve, and it's curving up in this case, okay? So arithmetic sequence creates a straight line. Geometric sequence creates a curve. All right, so to answer the question on number 3, which grows more quickly, the arithmetic sequence or the geometric sequence, and you can see that it's the geometric sequence because it's doubling each time. And then we're going to go down here and we're going to reintroduce the good old-fashioned recursive and explicit rules. But it won't be too bad. All right, so finding a term of a geometric sequence. For numbers greater than or equal to 2, the nth term, which we would write f of n, of a geometric sequence with the common ratio of r is going to be calculated this way. So the nth term is equal to the term before it. That's how they write the term before n. Okay, the term before n is n minus 1. So the previous term multiplied by r. So for instance, if you wanted the 10th term, then you would take the 9th term and multiply it by r. Okay? That is a recursive type of rule, meaning that you have to know a previous term in order to come up with the term that you do want. Okay? So that's a recursive type rule. If you want to turn the paper, you can, and we're getting a little bit ahead of ourselves, but you can also figure out an explicit rule for geometric sequences. So if you wanted the nth term, then what you would need to do is take the first term, multiply it by r raised to the n minus 1 power. So for instance, if you wanted the 10th term, then you would take the first term, multiply it by the common ratio, and then you would raise it to the 10 minus 1, or the 9th power. So it would be r to the 9th power times your first term to give you the 10th term. Okay, I'm now on page 548, and let's look at example 1, A and B. So it says to find the common ratio for each geometric sequence and use r to find the next 3 terms. Okay. So to find the common ratio, you can take the second value and divide it by the first, or you can take the third value and divide it by the second, or the fourth value and divide it by the third, etc. Okay, when you do that, you're going to get an r that is 2. Okay? So for this sequence, f of 1 is 6, the second term is 12, the third term is 24, the fourth term is 48. If the fourth term is 48, then the fifth term, remember we're going back to that recursive rule that we just looked at, the fifth term is going to be the previous term, or the fourth term, times our common ratio, which is going to give us 96. So now that we know the fifth term is 96, if we want the sixth term, then we take the fifth term, multiply it by the common ratio, and we get 192. Since we now know the sixth term is 192, we can find the seventh term by taking the previous, or sixth term, multiplying it by the common ratio, we get 384. Okay, so the next 3 terms after the first 4 that they gave you are 96, 192, and 384. Okay, so let's look at B. This time, our common ratio, be careful here. Remember, it's second term divided by first term, or third term divided by second term, or fourth term divided by third term, second divided by first, or third divided by second, etc. When you do that, you get 1/2. So the common ratio here is 1/2, or 0.5. Okay? So for this sequence, first term is 100, second term is 50, Third term is 25. Fourth term is 12.5 because you're dividing by 2 each time. Divided by 2 is the same as multiplying by a half. So if you know the fourth term is 12.5, the fifth term is going to be 12.5 times 0.5, which is going to give you 6.25. You now know that the fifth term is 6.25. So the sixth term is going to be the fifth term times the common ratio, which is 3.125. 3.125 is what you found for the sixth term. So the seventh term is the sixth term times your common ratio. When you do all that, you get 1.5625, and it just keeps getting smaller and smaller and smaller because, remember, you're multiplying by half each time. The next three terms, okay, so I went all the way and did like f of 8, f of 9, and f of 10. I think that they were wanting just these three, but that's fine. Okay, if you wanted the eighth term, then you would take the seventh term, multiply it by 0.5, and you'd get this. If you wanted the ninth term, you would take the eighth term and multiply it by 0.5, and you would get this. And if you wanted the 10th term, you would take the ninth term, multiply it by 0.5, and you would get this for the 10th term. Okay? So these are all doing it with a recursive rule, meaning that you would need to know the previous term in order to calculate the one that you wanted. If you wanted an explicit rule, remember the nth term is equal to the first term times r raised to the n minus 1. So if I wanted the eighth term, I would take the first term, multiply it by the common ratio raised to the 8 minus 1 power, or raised to the 7th power. Okay? And that's the way I would find the eighth term. All right. A geometric sequence has a common ratio of 3, and the fourth term is 54. What's the fifth term? What's the third term? Okay, so the fourth term is 54. I had to multiply something by 3 to get 54, which means the previous term I would get by doing the opposite of multiplying by 3, which is dividing by 3. So 54 is the fourth term. 18 is the third term. Again, going backwards, you would divide by 3, and you would get 6 for the second term. Divide by 3 again, and you would get 2 for the first term. So it goes 2, and then times 3, 6 for the second term, times 3, 18 for the third term, times 3, 54 for the fourth term. Times 3 would give us the fifth term. Okay? So this is the fifth term here. That's the third term. Okay?